Good evening everyone, welcome to Gradeup. I am Vikas Bhadoria and I welcome you to the live session on fluid mechanics important question discussion. So today we are going to solve some important question on the subject of fluid mechanics. So far in the subject of fluid mechanics, we have covered few important topics, that is fluid properties, fluid kinematics, flow through pipe, boundary layer, dimensionless analysis and hydraulic turbines. And today we are going to solve some important question of these topics. So I hope you have attended the lecture on these important topics. If you have not, then you can find these lectures on our YouTube channel, that is Gradeup YouTube channel, and you can go through them and you can practice some important questions. Okay. So today also we are going to solve some important question on these topics. So let's begin. We'll be waiting for some more students to join the session so that we can start discussing the question. This session is a very interactive session where we are going to solve some important questions, and this is will be an interactive quiz session. Okay, so for that you need to actively participate in this session, and so do come in the class and join the class. Yes. Good evening everyone, welcome to Gradeup. I welcome you all to this important session on fluid mechanics important question discussion. Good evening Puskari Joshiram. Good evening Praveen. Yes, a very good evening to you. I hope you have. So today we are going to solve the important question. FM is the most difficult subject among other, is it right? No, Jayaprakash, you cannot say that it is a difficult subject, because see, any subject can be difficult if you are not in touch of that subject. So definitely if you are not in touch of the subject of fluid mechanics, it will become difficult. Even the easiest subject will become difficult for you if you are not in proper regular practice of that subject. Okay. Yes, we have daily free classes on the YouTube channel. For that you need to subscribe to our YouTube channel, and we are conducting daily free classes for GATE 2020 on our YouTube channel for GATE Gradeup. So are you ready to solve some important question? Are you ready to practice some important question on fluid mechanics? So the topics we have covered so far in fluid mechanics, before we start this lecture, Abhishek Singh, definitely I will be continuing this subject of thermodynamics, but I am taking both the subjects, thermodynamics as well as fluid mechanics. Okay, so thermodynamics subjects I am already taking in the paid course, and also I will be coming for this subject of thermodynamics in the YouTube also very soon, and so I am taking both the subjects. Okay. So number of days left for the GATE 2020 is 100 days are left for that. So you need to take care of this number of days, because that with every day passing on, the number of days left for the GATE 2020 are also getting reduced by 1 day. Okay, so you need to take care of it, and you need to match your preparation with this timings. As the number of time is also reducing, number of days are also reducing for your GATE 2020. Okay, so you are coming close for your GATE exam. Okay. Now the topics that we have covered so far in this YouTube channel, and that we are going to solve important question on those topics. The topics are fluid properties, fluid kinematics, flow through pipe, boundary layer, dimensionless analysis. We have covered these topics on the YouTube channel, guys. Dimensionless analysis and hydraulic turbines. So these all topics have been covered so far on the YouTube channel from the subject of fluid mechanics. If you have not gone through this lecture, you can access to our YouTube channel for GATE Gradeup. There you can find the lecture on these topics, that is fluid properties, fluid kinematics, flow through pipe, boundary layer, dimensionless analysis and hydraulic turbines. Okay. And today we are going to solve some important question based on these topics. So those who have not joined our Gradeup app, we are going to start with interactive quiz session for this important question discussion of fluid mechanics from these topics. So please come on the Gradeup app so that we can start solving this important question from these topics of fluid mechanics. Okay. So this is your first question. Please solve this question. This is a question from the topic of fluid properties. Please solve this question, and then I will be telling you who has scored how much marks in this particular quiz session. And so please, the link for the app, Saeed Akhtar, you just need to download our Gradeup app. If you have already downloaded our Gradeup app, you will find this link for this particular live session for fluid mechanics important question discussion, and there you will get the link for the interactive quiz session. Okay. Yes. Pranav Chaudhary, very good evening to you. Yes, guys. So please start solving this question. I am giving you 2 minutes to solve this question, and then I will be discussing this question. Those who are not on our Gradeup app, please come on the Gradeup app so that you can get benefited by our interactive quiz session of fluid mechanics important question discussion. Yes, please solve the question. A fluid of density 1200 kg per meter cube at 1 atmospheric pressure is compressed to 101 atmospheric pressure. Isothermally, they have mentioned isothermally. Okay, if the isothermal compressibility is 4.8 into 10 power minus 5 per atmosphere, it is atmosphere pressure minus 1. The increase in density in kg per meter cube of the fluid is. Okay, so I am giving you 2 minutes to solve this question, and after that I will be taking the answers. Okay, so those who are in the app, I am giving you only 2 minutes to solve this question. Please solve the question. Imran Ammani has given option B. Okay. What about everyone else? Please solve this question. Yes, please solve the question quickly. Yes, please solve the question. Happy Singh, Hiten Navdar is getting option C. Ganesh Kumar is getting option C. Okay, Jay Prakash on the app is also getting option C. Okay, let's see what is the right answer for this question. I am going to take the answers. Those who are in the app, please mark your right answer. I am giving you options to mark. Yes, please mark the correct answer for this question. Abhinandan Kumar is getting option C. Please, it's my request to everyone, you can share to all your friends that this interactive quiz session on fluid mechanics is going on the YouTube channel of GATE Gradeup, so that more students can join in this session. Yes. Anju Das is getting option C in the YouTube channel. So we have 13 students in the app and some students in the YouTube channel. So let us see what is the right answer for this question. Yes, so we have got the result. Option C is the correct answer, which have been attempted by 10 students only in the app, and 80% have marked option C as the correct answer. So let us see how to solve the question. The question is very simple. They have given in this question that a fluid of density 1200 kg per meter cube at 1 atmospheric pressure. This is the condition which is given. It is now compressed to 101 atmospheric pressure isothermally. There is an isothermal compression. If the isothermal compressibility is given, that is 4.8 into 10 power minus 5, you have to find the increase in density. Okay. So we know that bulk modulus is equal to dP over minus dV over V, right? Or we can also say that this is equal to dP, or we can rho dP over d rho. And we know that in this question they have given isothermal compressibility. They have given compressibility, not bulk modulus. So bulk modulus will be equal to, compressibility will be equal to d rho over rho into dP, just reciprocal of bulk modulus. It is reciprocal of bulk modulus. Now, since you have to find the increase in density, this is the density that you have to find the increase in the density. So, this you have to find this value. Rho is given to you in this question, which is 1200 kg per meter cube, that is given in the question. dP is the increase in pressure. Increase in pressure will be equal to P2 minus P1. So, you have to find this increase in pressure. This will be equal to P2 minus P1. Now, the value of P2 is given in this question, which is 101 atmospheric pressure. So, this will be 101 minus 1, that is 100 atmospheric pressure. That is the increase in pressure. Density is also given to you, and the value of compressibility is given 4.8 into 10 power minus 5. So, you have to put all the values here. 4.8 into 10 power minus 5 is equal to d rho over 1200 into 100. So, from here, after solving this, you will get the increase in density equal to 5.76 kg per meter cube. So, that was a very good question, and it's showing coming soon in the Gradeup in my account. I don't know what happened to the app. Saeed Akhtar, if you are not getting the option for this interactive quiz, you can be present in this YouTube session, and so don't need to go anywhere. Just be present in the YouTube session. Don't worry. Yes, so the correct answer for this question is option C, that is 5.76 kg per meter cube. Okay. Yes, so this is the next question. Next question from the topic of fluid kinematics. So, you have to solve this question. In this question, it is given a flow field u is equal to 2x, while v is equal to 3y. Find the magnitude of acceleration meter per second square at the point 1, 2. Yes. Rahul Gupta, if your green card is showing for 288 rupees, that simply means that some of the Gradeup coins are also applicable. Some of the Gradeup coins are also applicable. Subham Agrawal, you are late for the session, no problem. We have just solved question 1. So, you can watch that question later also. So, please solve this question and tell me the answer. I am giving you 2 minutes to solve this question. I am giving you 2 minutes to solve this question. Yes. Come on guys, please solve the question. Use your calculator and solve the question. Please solve the question quickly. You need to participate guys in the session, then only you will get benefited from this interactive quiz session. Okay, these sessions are only for you guys, so that your preparation for GATE 20 exam can be improved, right? So, I just want active participation from you. I know Diwali week is coming, and so you must be preparing for your Diwali, but I just want everyone to be present in the session. So, please inform all your friends, colleagues to participate in this important session of fluid mechanics important question discussion, and that is very, very important for your GATE 2020 preparation. Yes. So, let us take the answers. I am going to take the answers in the app. Please mark your correct answer. In the YouTube channel, Anju Das is getting option B. Setu Suman is getting option B. Salman Ahmad is getting option B. Saeed Akhtar also getting option B. So, most of them are getting option B. Let us check what is the right answer. So, it's a very good question from the topic of fluid kinematics. Let's see what is the correct answer. Okay. Yeah, most of them are getting option B. Very good. Abhishek Gade is getting option B. Shubham is getting option B. Okay, so we are about to get the answer, or we can say response from you guys. Let's see what is the correct answer. Well, 17 have attempted this question in the app. 88% have marked option B. So, 88% have marked option B for this question. So, let us see the solution for this question. I hope most of you have marked option B in the YouTube channel also. So, you want to know the solution for this question. Let's see how to solve the question. In this question, it is given that a flow field having u component of the velocity is equal to 2x, v component of the velocity is equal to 3y, you have to find the magnitude of acceleration at the point 1, 2. Okay. So how to find the acceleration? We know that acceleration is equal to, total acceleration is equal to, in x direction, is equal to sum of du by dt, that is the local acceleration, plus u times of du by dx plus v times of du by dy, right? Also, we know that acceleration in the y direction is equal to dv by dt plus u times of dv by dx plus v times of dv by dy. Now, in this particular question, in this particular case of question, we know that these terms are 0. Why? Because they have not mentioned anything about the local acceleration. That is, the acceleration which will be varying with time. Okay, so that is not varying with time, so this term will be equal to 0. Now, we have to find the total acceleration. Total acceleration will be equal to under root of acceleration at x square in the x square and y direction. Because it is a two-dimensional flow field, the flow is varying in two-dimensional. So, the total acceleration will be equal to acceleration in the x direction square plus acceleration in the y direction square under root. Okay. Now, acceleration in the x direction will be equal to, ax will be equal to u, that is 2x into du by dx. Du by dx will be equal to 2 plus v, that is 3y into du by dy, that will be 0. Okay. So, you will get here ax is equal to 4x and ay will be equal to u times of dv by dx. U, that is equal to 2x into dv by dx. dv is 3y, so that will be 0 plus v, that is 3y. 3y into dv by dy will be equal to 3. So, you will get this as 9y. Now, you have to find the value of acceleration at the point 1, 2, when x is equal to 1 and y is equal to 2. So, when x is equal to 1 and y is equal to 2, ax will be equal to 8 and this will be equal to 18. Sorry, this will be equal to 4. Now, you have found the value of ax and ay. You just need to substitute these values in this equation and you will get the answer, that will be 4 square plus 18 square, and that will be 18.44 meter per second square, right? So, thank you so much. Those who have solved the answer correctly, that's really good. That means your concepts are really very good, because this question looks very simple, but actually a big concept is hidden behind this question, that you have to find the total acceleration. Now, total acceleration has to be found by magnitude of the acceleration in both the x direction and y direction. Okay. Yes, next question. From flow through pipe, or we can say from boundary layer. Boundary layer is a very, very important topic of the subject of fluid mechanics. So, this is a question from boundary layer. In this question, it is given that consider laminar flow of water over a flat plate of length 2 meter. If the boundary layer thickness at a distance of 0.2 meter from the leading edge of the plate is 4 mm, the thickness at a distance of 1 meter will be. So, again a very simple question from the topic of boundary layer. This question such type of question can be asked in the GATE exam in 1 marks. So, that's a very important question. Please solve the question. I am giving you 1 minute to solve the question. Okay. Yes. Please solve the question quickly. Take out your calculator if you have not. Take out your calculator so far, because this is a GATE type question. So, please. AP Kumar, that's really good that I have taught you in this lovely professional university, and so I am also happy to talk to you after such a long time, and so enjoy the session, and I wish you all the best for your GATE 2020 preparation. Will these videos will be available after live? Yes, definitely. The videos will, you can access the video after the live session in the YouTube channel. Definitely they will be available. Yes, solve the question quickly and then I will be telling you what is the right answer for this question. Come on guys, please be a part of this interactive quiz session and prepare for a GATE 2020 examination. Your GATE 2020 examination is just 100 days away from now, and so you should actively participate in this quiz session. Feel the competition, guys. Feel the competition. The number of students that whom you are competing, you are present in this live session. Okay. Now you can know who are your competitors by being present in this interactive quiz session. Sir, I'm getting B. It's correct. Okay. So Shubham Agrawal is getting option B, and most of the students in the YouTube channel are getting option B or option A. Some of them also getting option A. All right. Naveen is getting option B. Maddie Ban is getting option D. Pranav is getting option G. Well, Pranav, there is no such option as option B. Well, everyone will not get the answer. I'm not saying not going to say yes or no. I'm going to check the answers now. So I'm going to take the answers in the app. Those who are in the app, please mark your answer now. Please mark your answer now. I hope this question is clearly visible to you all. I don't want to be hiding this question. So please solve the question. It is a very simple question. And so I want most of you to be correct for this question. It's a very simple question that can be asked in the GATE exam. You have to use the relation for boundary layer thickness in the case of laminar flow. Yes, I'm going to get the response. Yes, we have got the answer. 14 have attempted this question in the app, and out of them, 79% have marked option B as the right answer. So let's see how to solve the question. See, in this question, they have asked you relation for laminar flow boundary layer thickness with the distance from the leading edge. Now we know that in the case of laminar flow, boundary layer thickness is equal to 5 into x over under root Reynolds number. Now you got all the rights to use this equation for boundary layer thickness if velocity profile is not given. Please, if velocity profile is not given, then you can definitely use this equation. Now, I'm going to show you the rank list. Don't worry, Rahul Verma. And right now you are on the top, followed by Mageshwaram, Praveen, Abhishek Singh. These are right now on the top. So this relation you can use if velocity profile is not mentioned. If no velocity profile mentioned, in the case of boundary layer, if no velocity profile and it is a laminar flow, in that case you can use this equation for boundary layer thickness. Now you need to get a relation for distance of the boundary from the leading edge and the boundary layer thickness. Now we know that in the case of boundary layer, this distance from the leading edge, that is from here, this distance, there is some relation of this distance from the leading edge with the boundary layer thickness. There is some relation for that. And what is that relation? Let us find that. We know that this delta is equal to 5 into x into under root of Reynolds number is rho into v into x over mu. Now if you take this here as, this will be 5x divided by into root x over under root of rho v by mu. Now we just need to have to find the relation of boundary layer thickness and this x, that is the distance from the leading edge. So what will be the relation? It will be, x power minus 1 by 2. So you will get this relation that delta is actually proportional to root x. This relation you will get for the laminar boundary layer thickness with distance from the leading edge. Now this is directly proportional to this. So what you will get from here, delta 1 over delta 2 will be equal to under root of x1 over x2. Now delta 1 is the distance of boundary layer thickness in the case of first case. So that will be equal to the boundary layer thickness at a distance of 0.25 meter from the leading edge of the plate is 4 mm. So this is given as 4 over delta 2 is equal to 0.25. And now we have to find the distance of the boundary layer at 1 meter. So this is 1. So from here you will get that boundary layer thickness delta 2 will be equal to 4 divided by root of 0.25. You will get 8 mm after solving this. So the right answer that you will be getting is option B, which is 8 mm. Okay. Next question again from boundary layer. Now this time you have to find the relation of the turbulent boundary layer thickness with the distance from the leading edge. Okay. So please solve the question, read the question carefully and tell me the answer, that what is the right answer for this question. Okay. I am giving you 2 minutes to solve this question. Take your time and solve the question. Yes. Please solve the question quickly. Shubham Agarwal is getting option B, very quick, option A, sorry. So far, I'm going to show the leaderboard also. I will be showing leaderboard after this question. I will not be saying any option now. Please keep your answer with you, and I will tell you the right answer after I will take the answer from you in the app. Okay. Those who are in the YouTube channel, you can give your response. Please solve the question. Again, an important relation of turbulent boundary layer thickness with the distance from the leading edge will be used. Now in this question it is given that in a turbulent flow over a flat plate, boundary layer thickness at a distance of 6 meter was observed to be 6 mm. The boundary layer thickness at a distance of 8 mm will be in mm. So please solve the question and tell me the answer. Okay. Yes, guys, please take your time and solve the question. I'm going to take the answer. Yes, so those who are on the YouTube channel, you can give your response. I will be telling you what is the right answer for this question after I will take the answer in the app. Okay. So I'm going to take the answer in the app. Yes, please mark your right response. Hiten, Mrithun, Abhinandan Kumar. Abhinandan Kumar getting option A. Manoj Patil getting option A. Salman Ahmed getting option A. Setu Suman option B. Pranav Chaudhary option B. Okay. So we are about to know what is the right answer for this question. Please wait. Yeah, total 13 students have attempted this question in the app, and out of them 92% have marked option A as the right answer. 92% have marked option A as the right answer. That's really good. Now in this question you have to find the relation of turbulent boundary layer thickness with the distance from the plate. How we will get the relation? Again, velocity profile is not mentioned. If velocity profile is not mentioned, if velocity profile not given and it is a turbulent flow, then in that case the boundary layer thickness will be equal to 0.371x over Reynolds number power 1 by 5. So this is a relation if velocity profile is not given and you have to find the turbulent boundary layer thickness relation. Now, how to find this question, how to solve this question? You have to again find the relation of boundary layer thickness with the distance from the leading edge of the plate. How to find that relation? Reynolds number is equal to Reynolds number power 1 by 5. Okay. Now you just have to find the relation of boundary layer thickness and x. How to get that relation? Very simple. We know that delta will be equal to directly proportional to x over x power 1 by 5. Right? Or we can say that it will be equal to x power 1 into x power minus 1 by 5. After solving it, you will get delta is directly proportional to x power 4 by 5 for turbulent boundary layer. So this is the relation that you will be getting. The thing I made mistake in hurry in previous problem is that I interchanged value of delta and x. Very good point to remember. Yeah, definitely. So please don't forget to interchange, mark your current, firstly find the correct relation and then put the value of whatever value is given in the question in the relation. So the relation that we have got is delta is directly proportional to x power 4 by 5, where delta is the boundary layer thickness in turbulent flow. So we can get that delta 1 over delta 2 is equal to simple x1 over x2 power 4 by 5. This is the relation that you are getting, guys, right? Now, in this question, the boundary layer thickness at a distance of 6 meter was observed to be 6 mm. That is given to you 6 mm. The boundary layer thickness at a distance of 8 mm has to be found. So, initial thickness is, that is 6 mm delta 2 is equal to, at a distance of 6 meter was 6 mm. So, this is 6 and this is value is given as 8 power 4 by 5. After solving this relation, you will get the value of delta 2. The delta 2, that is boundary thickness at distance of 8 mm 8 meter will be equal to 7.5 mm, 55 mm. Okay. So you have to remember this relation for boundary layer thickness in the case of turbulent flow, that is delta power, that is boundary layer thickness is directly proportional to x power 4 by 5, where x is the distance from the leading edge of the plate. Okay. And in the case of laminar flow, it is boundary layer thickness is directly proportional to square root of x. Okay. So I am not going to show you the third question, but before that, sorry, not third question, it is the fifth question. Let us see the leaderboard. I am making it public in the app. So please see the leaderboard. Right now, Rahul Verma, Mageshwaram, Praveen, Abhishek Singh, they are on the top right now. So very good, guys. And those who are not, those who are trailing back, like those who are on second position, Sitaram, Abhishek Gade, Dakshyas Bhatt, Shubham Agarwal. Still you have left with 4 questions, you can be on the top. Okay, so the competition is still going on. You can also mark all the other question correct and you can be on the top. Okay. So this is the next question. This question is from hydraulic turbines from Pelton wheel. Please solve the question, read the question carefully. Subrata, very good evening to you. Well, Shubham Agarwal, yes, if you are not able to mark the right answer, definitely that is due to some problem in your app. So it will be better that you just reload your app, or you can again start your app. I hope the problem will be resolved. Okay. Yes, a Pelton wheel is working under a head of 45 meter and discharge is 0.8 meter cube per second. The mean bucket speed is given as 14 meter per second. The jet is deflected by blades through an angle of 165 degree. Take coefficient of velocity as 0.985 and mechanical efficiency as 0.95. Thus, shaft power produced in kilowatt will be. Yes, guys, solve this question and tell me the answer. What is the right answer? I will be giving you 2 minutes to solve this question. Yes, you can remember the direct relation. You don't need to derive the relation for boundary layer thickness. You can remember the relations. These relations are very, very important. They can be directly used in the exam. So for laminar flow, boundary layer thickness is directly proportional to square root of x. X is the leading edge, distance from the leading edge of the plate. And for turbulent flow, it is directly proportional to x power 4 by 5. Okay. So you can remember this relation. They can be useful for the GATE exam directly. I'm just moving aside so that you can see the question and option, and please solve the question. I'm giving you 2 minutes. This kind of question I have already solved in hydraulic turbine lecture. That lecture was already we have conducted in the YouTube channel. So if you have attended that lecture, definitely you will solve the question. You have to use this in this question. You have to find the relation for runner power for the Pelton wheel turbine, and after that you have to find the shaft power. Remember, guys, they have asked the shaft power, not runner power. Okay. So please correctly see the question and then solve the question. So we are going to get the answer now. I hope you have solved the question in the app. I'm going to take the answers. The time starts now. You can mark your response. In the YouTube channel, Salman Ahmed is getting 335. There is no such option, Salman, like 335.77. Jainam Shah is getting option B. Kumar Vasu is getting option D. Okay. Yes, guys, please solve the question. Those who are in the app, I am going to take the answers. Subrata is getting 325.445. That is option C. Okay. So let us see what is the right answer. We are coming on that. Please wait for 1 second. Yes, so we have got the result. Total 12 students have attempted this question in the app and 58% have marked option B as the right answer, which is also the correct answer, while 42% have marked option C. Well, these two options are quite close to each other, but well, option B is the right answer. So let us see how to solve the question. I hope I think you guys have done some mistake in solving the question. So in this question, you have to find the value of shaft power. Now shaft power, if I have told you this relation, in the case of Pelton wheel, we know that water power goes to runner power, then runner power goes to shaft power. Now the ratio of runner power over water power is equal to hydraulic efficiency, and the ratio of shaft power over runner power is equal to mechanical efficiency. Now in this question, mechanical efficiency is given to you in the question. You have to find the shaft power. How to find the shaft power? If you will get the value of runner power for the Pelton wheel turbine, you can get the shaft power. How to get the runner power? Runner power is given by runner power is equal to rho into Q into U into V1 minus U 1 plus cos phi. This is a formula for runner power for Pelton wheel turbine. Now, in this runner power formula, the rho is the density, Q is the discharge, U is the mean bucket speed which is given to in the question, that is 14 meter per second. V1 is the velocity of the jet. Now this jet velocity has to be calculated. Phi is the angle which is the leaving angle of the blade velocity. Now this leaving angle phi is equal to 180 degree minus the angle of deflection, which is given as 165 degrees. So this phi will be equal to 15 degree. You just need to find the value of V1. How to get the value of V1? V1 is the velocity of the jet. This is equal to CV under root 2GH. Now H in this question is given, where it is equal to 45 meter, and CV is given to you, coefficient of velocity is equal to 0.985. Just put all the values, it will be 0.985 into under root of 29.81 into 45. You will get the velocity here. You have just have to put the velocity in this equation and you will get the value of runner power. Now after getting the value of runner power, you have to substitute this value in this equation. Shaft power will be equal to mechanical efficiency into runner power. So those who are not getting the right answer, just tell me, were you doing the same mistake? You have not multiplied mechanical efficiency with this runner power. That is why you are not getting the right answer. Okay. So if you will multiply this runner power by mechanical efficiency, you will get option B as the right answer. Okay. So please read the question carefully. Otherwise, you will land into wrong answer. Okay. Next question from this hydraulic turbine again. Consider two hydraulic turbines having identical specific speed and effective head at the inlet. If the speed ratio N1 by N2 of the two turbines is given as 2, then the respective power ratio will be. Yes, please solve the question carefully, and I am giving you only 2 minutes to solve the question. Yes, solve the question quickly. I hope you are able to see the question clearly. Please solve the question. You have to use the relation for a specific speed of two hydraulic turbines and you will get the answer. That is a small trick, or we can say a small hint for this solving this question. Bhaganna Walikar is saying, sir, this is also civil. No, well, definitely this topic of fluid mechanics is also for civil branch. So definitely this topic is for civil students also. So don't worry, this classes also the classes for fluid mechanics are common for both mechanical and civil. So if you want, you can also participate in this interactive quiz session. Yes, I think the question is very simple, so you must have solved this question. I am going to take the answers in the app. So all those students who are present in our app, please mark the right answer for this question. I am giving you options. In the YouTube channel, Hiten is getting option C, Subrata is getting option C, Abhinandan Kumar is getting option C, Naveen option C, Madis option C, Setu Suman option C, Bhaganna Walikar is getting option C. Okay, let's check what is the right answer. So we are about to get the right answer for this question. What is your response in the app? And then I will be telling you who has marked the answer correctly. Total 14 have attempted this question. 93% have marked option C as the correct answer. 93% have marked option C as the right answer. Now, how to solve this question? In this question, it is given that two hydraulic turbines having identical specific speed. The hint is given in the question itself that these are having two identical specific speed. Identical means same. So, specific speed of the hydraulic turbine is equal to n root p h power 5 by 4. Now, in this question, the specific speed, you have to find the ratio of power P1 by P2. Now, if you equate this, you will get N1 root of P1 over H1 5 by 4 is equal to N2 root of P2 over H2 5 by 4. So, I think you have used the same relation. Now, in this question, one more clue is given that if the specific speed ratio of the two turbine is 2, the speed ratio N1 by N2 is given as 2. Also, the two turbines having identical specific speed and effective head at the inlet. Identical specific speed and head at the inlet. That is, head also same. So, H1 is also equal to H2 and N1 by N2 is equal to 2. So, this H1 is equal to H2, this will get cancelled out. You have to just find the relation of root of P1 by P2 will be equal to N2 by N1. So, you will get P1 by P2 is equal to 1 by 2 of whole square. So, from here you will get this, that this is 1 by 4, that is 0.25. And that is the right answer. The right answer is option C. Next question. Again a very good question from the topic of fluid kinematics. Please read the question carefully and solve the question. The velocity of the fluid particle in a two-dimensional flow is given by v is equal to x cube y square I plus y cube j. Calculate the slope of the streamline at the point 4, 2. Yes, guys, please participate in this interactive quiz session. It is very important for your GATE 2020 exam preparation. So, please inform all your friends, near friends, dear friends, everyone to participate in this interesting quiz session and improve your preparation for GATE exam. Okay? Yes, solve the question. Again, a very good question from this fluid kinematics. Yes, guys, please quickly solve the question and tell me what is the right answer for this question. Siva Reddy is getting option C in the YouTube channel. Krish Dukshes C, option C. Saeed Akhtar, option C. Hiten is getting option C, all right. So, I am going to show you the leaderboard after this question. Rahul Verma, don't worry. Right now, those who are on the top is Mageshwaram and Praveen. They are on the top with 60 marks. While Rahul Verma, you are on the second position with Dukshes and Abhishek Singh. So, I am going to take the answers in the app. Please mark your right answer. Abhinandan Kumar is getting option C, that is 1:32. Well, most of the students in the YouTube channel are getting option C as the right answer. So, let us check what is the correct answer for this question. Yes, we are about to get your response and then I will be telling you what is the right answer for this question. Yes. So, total 15 have attempted this question and option C is marked by 87% students. 87% have marked option C as the right answer. Now, this question is from the topic of fluid kinematics. And in this equation, you have to find the equation of streamline for a two-dimensional flow. Now, for a two-dimensional flow, equation of streamline is given by dx over u is equal to dy over v. Had it been a three-dimensional flow, the equation would have been dz over w. But since it is a two-dimensional flow, so you will be using only dx over u is equal to dy over v. Simple. If you don't know this equation of streamline, I hope you have got a new formula, guys. So, this is the equation of streamline in three dimension and this is the equation of streamline in the two dimension. Now, what you need to find? You just need to find the value of u and v. Now, in this equation, v is equal to x cube of y square I plus y cube of j. This part is your u part, this is your v part, v component of velocity. So, u component of the velocity is equal to x cube y square and v component of velocity is y cube, right. So, this is the equation of two-dimensional streamline. So, you will get dx over x cube y square is equal to dy over y cube. You have to find the slope of the streamline. Slope of the streamline is equal to dy over dx. Now, dy over dx will be equal to y cube over x cube y square. From here, this will get cancelled out. You will get y over x cube. So, dy over dx, which is the slope of a streamline, is equal to y over x cube. Now, the value of y component is given as 2 and x component is given as 4. You have to just substitute the values. It will be 2 divided by 4 cube and you will get as 1 by 32. So, the slope of the streamline for this two-dimensional flow field is equal to 1 by 32, which is the right answer for this question. Okay. Now, this is the last question for the day. I hope I will be showing you the leaderboard after this question. Okay. Right now, Praveen is on the top with 70 marks and Rahul Verma is at the second position with Mageshwaram, Dukshes Bhatt and Abhishek Singh. They are on the second position and Vivek Patel, Sitaram Shah, there are so many on the third position. So, still right now Praveen is leading with on the leaderboard with 70 marks. He has answered all the 7 questions correctly. Now, it's still chance for Rahul Verma, Mageshwaram and Dukshes to be on the top, also Abhishek Singh. Please read the question carefully. A non-Newtonian fluid is flowing in a floor having height of 5 mm and with a free stream velocity of 0.5 meter per second. For such a fluid, the yield stress is 38 megapascal. The exponent index n is equal to 1.32. and the fluid coefficient A is equal to 1.6. The shear stress of the fluid in megapascal is to be determined. Yes, please solve the question carefully and let me know what is the answer for this question. I will be taking the response in the app after 1 minute. Okay? Because that is the actual time that you should take to solve the question. You just need to apply a single formula and you will get the answer. So please read the question carefully and tell me the answer. Yes, solve the question quickly. Then I will be taking the answers in the app. Those who are on the YouTube channel, please tell me the answer. Equipotential line, if you need to find the equipotential line, Subham Agrawal, in the case of this velocity potential, slope of equipotential is equal to dy over dx is equal to minus u by v. This is for equipotential line. And for streamline, this is dy over dx is equal to v by u. Okay, Subham Agrawal, I hope it is clear now. I hope your doubt is resolved now. Okay. Yes, I am going to take the answers now. Let me check how many of you have marked or solved this question correctly. Yes, guys, please solve the question because I am going to take the answers response in the app. So please mark the correct response. In the YouTube channel, Shakshi Pandit is getting option B. Sai Kiran is getting option 736.42, that is option A. Mehdi Ban is getting option B. Subrata is getting option B. Sai Karan is getting option A. Okay. Kumar Vasu is getting option A. Alright. Abhinandan Kumar, option B. So we are about to get the right response. What is the right answer for this question? Please wait. Well, 15 have attempted this question and only 7%, I don't know why, but only 7% have marked option A as the right answer, which is also the right answer. This is very bad. Only 7% have marked option A in the app. While option A is the right answer and only 7% have marked, while 53% have given option B as the right answer and 40% have given option C. So that is not a good thing. Let us see how to solve the question. Well, this is a non-Newtonian fluid. A non-Newtonian fluid is given and we know that for a non-Newtonian fluid, the equation is shear stress is equal to A du by dy power n plus b. Now, normally we use such type of equation for non-Newtonian fluid. For Newtonian fluid, we know the relation is simple. It is equal to mu of du by dy. This is for Newtonian fluid. And this is for non-Newtonian fluid. How many of you have used this relation? Tell me, guys. How many of you have actually used this relation for solving the yield stress value? Those who have used this equation, they have definitely got the answer, but I can see only 7% have solved it correctly. So definitely your approach is not correct. It is a very easy question from the topic of fluid properties, but still only few students have solved it correctly. Now, A is the value of fluid coefficient. It is the value of fluid coefficient, that is 1.6. du is the change in velocity, that is 0.5. That is given to you, 0.5. dy is this height, that is 5 mm. That is 5 mm. So it will be converted in meter. Sorry, that will 5 × 10 power minus 3 meter. Power 1 by 1.32. Now you have to add this B. B is the yield stress. Yield stress is that if you see this stress strain curve, non-Newtonian fluid, this value is called yield stress. this minimum stress which is required for the fluid to flow for non-Newtonian fluid is called yield stress, and this value is given as B in this particular case. So you have to add this value of B, which is given to you 38 megapascal, right? And after solving this value, you will get 736.42 megapascal as the answer. So those who have solved this question carefully, that's really good, but that is a very easy question. If you have not solved this question correctly, that means you again need to revise your concept of fluid mechanics subject. Okay, well, these lectures you can use it for both civil engineering or mechanical engineering, because fluid mechanics is a common subject for both mechanical and civil branch. Okay, all right, so we have reached to the end of this lecture, and before that I want to show you the leaderboard. So in the leaderboard, if you see the leaderboard, we have Praveen on the top. Praveen is on the top with 70 marks or 70 score, followed by Vivek Patel is on the second position, Rahul Verma on the second position, Mageshwaram on the second position, Dukshes is on the second position, and Abhishek Singh on the second position. And on the third position, there are so many of them. Not so many, Sitaram, Abhishek Gade and Rahul Gupta, they are on the third position. So these are top 3. All right. So I hope you have understood all the question, and Praveen, that's so humble of you that if you say that you know nothing, but you have solved all the question correctly, that's really good. Your preparation is really going good, but you also need to revise your concept, because if you leave any subject, that will become a tough subject. Okay. So like some of the students were saying in the beginning of this session that fluid mechanics they find very tough, but any subject can be tough for you if you are not studying that subject carefully, or if you are leaving that subject. Okay, so don't ignore any subject. Please give proper time for all the subjects. Okay. So Rahul Gupta is asking about the price. So I hope most of you know about this thing. Gradeup is providing you this Gradeup green card. We have launched Gradeup green card 2 days back, and in this Gradeup green card, I hope you know about it. Those who wants to purchase our test series, now you don't have to wait for our test series to launch our test series. You can just buy a single green card. If you will buy this green card, you will have an access to all the test series in the particular month or year. So this green card we are providing in 2 ways. One is monthly green card, other is yearly green card. In the monthly of the green card, you can have a right to access all the test series related to all the engineering exams like ISRO, BARC, GATE, SSC. You can access all the test series in that particular month. But if you have bought 1 year green card, and that too in this 3 days, only 1 day is left, from 22nd of October, this Diwali offer started from 22nd to 25th of October. So tomorrow is the last day for this Diwali offer. In this Diwali offer, our yearly green card, which will provide you access to all the test series up to 2020 December. Or we can say if you are purchasing this now, you will have this access up to 25th of October 2020. Now, for that, if you buy this green card in this yearly green card, up till 25th of October, you have 3 offers that you are going to get. One offer is flat 25% off, on the yearly card. With this flat 25% off, you will get our yearly green card at 375 only. You can also use your Gradeup coins. If you are having any Gradeup coins, your Gradeup coin will also be reimbursed here. Okay, so you can also use your Gradeup coins in this Gradeup green card. Okay, so right now the price, if you are purchasing this yearly green card, right now up till 25th of October, first thing is flat 25% off, and you will be getting this at 375. ISRO test series is not activated, Rahul Verma, because ISRO test series is going to be launched in the month of November. It is going to be launched in the next month. Okay, so we have to wait for that. And the second thing is, if you are buying this course up if you are buying this green card till 25th of October, you will get an extended validity of 2 months. Okay, so you will have total validity of 14 months if you buy this green card right now up till 25th of October. So not only you will be getting this flat 25% off, you'll also be getting this 14-month validity. So your validity for yearly green card will be extended for 2 months. And the third and important thing, to make your Diwali more interesting, you can get a chance to win OnePlus 7T and Redmi 7S every day. Okay, so you can be a lucky winner and you can get a chance to win OnePlus 7T and Redmi 7S if you buy this green card up till 25th of October. No, Subham Agrawal, this mobile is not, there is nothing false in that. You can get this detail about this, our daily winners. Every day, some of the lucky winners are getting the mobile phones. If you are accessing our Gradeup app, you can find the pictures or photos of all the winners of this mobile phones. Okay, so every day we are distributing lucky mobile phones to lucky winners. All right. Now, those who are, see this channel, these classes were on the YouTube channel, and right now we have conducted a session on the YouTube channel for the topic of fluid mechanics. Okay, and there will be regular classes like this on the YouTube channel for GATE 2020 and also for ISRO 2019. Okay, but if you want to purchase any paid course, right now we are running a paid course for mechanical, that is Rank Up GATE ME paid course. This Rank Up GATE ME paid course is a 100-day crash course having 300+ hours of live classes, like with this interactive quizzes. Those who have already purchased this course, that is really good. Those who have not, offer is really running out. So please hurry up, guys, because your number of days left for the GATE exam is exactly 100 days now. And this is a perfect course in a 100-day crash course for the GATE exam. 2000+ numerical question will be discussed live here in the class in this paid course. 24 subject tests, 4 part tests and 7 mock tests will be included. And those who have already bought this paid course, they are automatically upgraded to green card. Okay, you have automatically updated to green card. You have got the right to access all the test series till the validity of this course. Okay, topic wise quizzes and PDF for revision you will also be getting for this Rank Up GATE ME course. Now there are offers. There are definitely some offers for our GATE qualified students. If you have qualified the GATE exam in the year 17, 18 and 19, you have a chance to win 50% off on the MRP. Okay, so this course will be available to you at the price of 7,000, approximately 7,000. Okay, so you will have a chance to win this, or you can have a chance to win this scholarship for 50% off. And also for GATE qualified student in the 17, 18, 19, you can have the chance to win 50% off on the MRP. Along with that, this offer is for IT and IT BTech students. That is also a nice offer right now. And I think those who want to prepare for the GATE exam, it's a really nice offer. You can access this offer and you can prepare for your GATE 2020 examination. All right. So if you have any doubt regarding anything related to subject, related to any course or green card or this Rank Up GATE ME course, you can ask your doubt in the doubt section. And all right, also if you have any feedback, for us, for Gradeup, you can also provide your feedback in the comment box. And don't forget to subscribe to the YouTube channel, because if you are not subscribing to the YouTube channel, you will not get any update. See, normally we provide you notification for any session like this, but if you have subscribed to the YouTube channel and press the bell icon, you will get automatic update on your mobile phone regarding any session like this. Okay, so please subscribe to the channel and press the bell icon, that is required. Okay, and in the end, I just need to, I cleared GATE 2014, 15, 16, 17, 19 except 2018. Yes, definitely, Chanduru, if you have cracked the GATE in 2017 and 19, you can definitely avail this offer, because this offer 50% off on the MRP was for all the students who have cracked the GATE, qualified the GATE in the year 17, 18 and 19. All right. So this is all. This is at the end of the session. I hope you have liked the session. If you have really liked the session, please press the like button and do subscribe the channel. I have already told you the benefit of subscribing the channel, that you will get the new updates regarding any session which we are going to conduct on the YouTube channel. Okay. So I will see you in some other session. And also, how can I forget? This is Diwali week. So happy Diwali to everyone. And I will see you in some other session. And thank you and have a good day. Happy Diwali to everyone. Celebrate Green Diwali with Gradeup and buy our Gradeup green card. Okay. Yeah, Abhishek Singh, I will definitely be continuing thermodynamics in the YouTube channel also, and already taking this thermodynamics in the paid course. Alright. So see you everyone. Happy Diwali. Have a good day. Thank you.